Okay. So I'll change the slide. I'll change the slide. Okay. Share. Just wait for 1 or 2 minutes to come into picture the actual slides for the partial differential equation. Differential equation is well known to you. dy dx. If y is equal to 2x plus 1, dy dx is 2. This concept is already there, but this is not the end of it, because partial derivative. What is partial derivative? There are you are looking into this picture now. That is, yes, partial differentiation. Why the concept of partial differential equation is there? Let me discuss it. We have y is equal to 2x plus 1, suppose. Then there is no question of partial differentiation. Just make a just because this is a problem in the small right hand. Can you say it properly? Can you say it properly?
Yes, sir.
Yes.
A partial differential comes only when there are 3 variables. More than 2 variables. If there are 3 variables, 4 variables, 10 variables, then the question of partial differential equation. One thing, that is, if you want to suppose z is equal to function of x and y, both x, y are there. Suppose z is equal to 2x plus 3y. Then, if I want to differentiate, that is, if I want to find out with respect to x, derivative, partial derivative with respect to x, then what will happen? Y will be taken as constant. Then I can differentiate. I will come to the problem afterwards. Suppose I want to find out partial differentiation of z with respect to y, then I'll keep again they're coming back. So what can I do? Okay, I admit, because the first one, the first day, everybody cannot time. Again, admit. Okay, right. There is the concept of del z del x, del z del y. Otherwise, if it is function of 2 variables, I will write dy dx. There is no question of partial differentiation. But if there is more than 2 variables, suppose z is equal to 2x plus 3y is a function of 2 variables, then the question of partial derivative comes. I will just literally I am telling you, this is the fact. Then, as in that differential equation case, differential calculus of 2 variables, there are also limit holds. That is, limit x tends to a, limit y tends to be fxy. Now the function is fxy. I am dealing with fxy. Limit of this will be the limit, that is L. If I want to find out the limit x tends to a, y tends to be fx, then we get some limit, it is L. And alternate definition, the limit of the function fxy will be, you can see the this in the picture, limit of the function fxy tends to L whenever fxy minus L modulus is less than certain small quantity, as in the two dimensions case. Okay, this whole question I am discussing. This one, that is fxy minus L modulus will be less than some small quantity whenever it will be, the small quantity will lie between 0 to delta. This is the official definition, but I will tell you the technique how to find out the partial difference. Running out of time. oh, this meeting will end it. If it ends, then you just think that I will just call for another meeting. This way. Okay. Okay, this is the condition. But literally, I will tell you how to do it. Not that I'll have to do always this type of calculation, not like that. There are easy methods to find out the limits. Okay. Then continuity, as in the general function. If the left hand side and right hand side limits are equal and equal to the function, equal to value of the function at the point, then it is a continuity. Function is continuous at the point. See, yes, this one. Okay, 1 second, because this is a difficulty in Zoom. Yes, this is the definition of continuity. No, never mind. And also the fx is said to be continuous, okay, but generally it is same. Generally it is same as written in this line, that limit x tends to a bracket, limit y tends to be fxy is equal to limit y tends to be limit x tends to a limit x tends to a fxy. Usually this is matching. Then the function is continuous, but sometimes it does not happen. This two-sided limit may not be same. Yes. Anybody wants to know anything? Anybody want to know anything?
No, sir. You can continue, sir.
Okay, some sound is coming. That's why I'm telling. Okay. That y, suppose y is equal to mx. If I put y is equal to mx here, then what will happen? Then it is come the earlier limit is 1. Earlier limit is 1, and later limit is 2. The substitution of the value. See, just you substitute the value, you'll find out the two limits. These two limits may be different. See, that's what I'm telling you. Usually it is not different. Right. So this is the, say, this is the problem. Okay, but this, what is happened to that? Oh, it is going to end. Okay. Again. Page 1 has come. Oh, yeah. Just I'm just equate it up to the point. Say now it is not possible to admit anyone now onwards, because this page I'm coming with size. This is okay, but I'll dictate you how to find out the limit. Suppose the problem is that limit x tends to 1, y and y tends to 2. You find a value of 3x square y by x square plus y square plus 5. Or simply you set the limit earlier 2, because at the bottom there is y tends to 2. So you substitute 2 instead of y, and then you substitute 1 in place of x. That value is 3.5. See, 3.5. This one. See, this is the evaluation of this limit. X tends to 1, y tends to 2. Then what happened? You substitute value 1 by 1. That is, first you substitute y tends to 2. That is, y is equal to 2.
Sir, can you explain example one more time, sir?
One more time. Please
Sir,
see this
can you
problem.
please use the marker?
No, this is the simplest problem. just this problem.
No.
See it. See it. Limit x tends to 1, y tends to 2, 3x square y divided by x square plus y square plus 5. Right? Then you have to substitute firstly y is equal to 2, because this is C. You can see that first I have substituted y is equal to 2 here. Then I have substituted x is equal to 1 there. And ultimately the value becomes 3 by 5.
Sir, if
What
we
is the
substitute x
problem?
first, then
Problem
it
is
will
that
be
this is the usual way
incorrect,
of
sir.
finding out the value of the limit. Right? So value of this limit, there is a sample example number 1. Value of this limit is 3 by 5. I think it is nothing is wrong is there, because y first and then substitute x. Y is equal to 2, then x is equal to 1. You get 3 by 5.
Sir, if we substitute x first, then it will be incorrect, sir.
So how to do it? You told?
Sir, if we first
Yes.
substitute x in the place of y, sir,
No.
then
First of all, you have to substitute. Oh, acha. If it is reversed, then also there is no problem. You can substitute x is equal to 1 first, and afterwards you can find y is equal to 2. Then the
Yes, sir.
answer will be 5. Anyway, any kind,
Yes, sir.
either x first or y first. There is no such limit. The restriction is there, no such restriction. Second problem you come. Second problem, example number 2. See carefully that limit x tends to 0, y tends to 0, 2xy by 3x square plus y square, right? So solution, limit x tends to 0, solution is first you substitute y is equal to 0, because y tends to 0, so you put y is equal to 0. And then x tends to 0, you put x is equal to 0. So it is come 0 by 0. We know from differential calculus that if the limit comes as
0 by 0.
0 by 0, if it comes,
0 by 0.
the limit does not exist. It is true enough. We had the knowledge from the just your class 12 knowledge. 0 by 0 form, if it comes, it does not exist. 0 by 0 or infinity by infinity, if this kind of form is coming, then the limit does not exist. Then example number 3, just because this is first class, we shall just coming to the point how to deal with this problem. Evaluate limit x tends to infinity, y tends to 3, xy plus 4 divided by x square plus 2y square. Then pointer I am using that then you first substitute the value. What is the pointer? Firstly, it is xy plus 4. Then you substitute the limit of y is equal to 2, because y tends to 2 is there. If you put y tends to 0, then it comes to limit x tends to infinity 2x plus 4. Right? Example number 3. Limit x tends to infinity 2x plus 4. Why x square plus 8? Still it is not complete. X tends to infinity is there, no? So x tends to infinity. So just x tends to infinity means 1 by x tends to 0. Then what will happen?
Please use the pointer. We are not able to follow.
I am using the pointer, but it slips.
Or the
This one. You can see the pointer.
okay, sir.
This is x tends to infinity 2x plus 4 by x square plus 8. Pointer is slipping. Then limit x tends to infinity, dividing on both numerator and denominator by x square. Then it will come 2 plus 4 by x, and here Can I start it once again?
Yes,
Six
sir.
people are voting.
Yes,
From
sir.
that point I'm
Yes, sir.
starting. But I'm giving a admit on still it is showing 64. Okay, quickly join it because no, mathematically how to do it. That's what I am telling. Nothing wrong. Okay, almost there. So just sharing the same material.
अभिनीत तो वीडियो भी चला देता.
Just sharing the screen, coming to the same point. Okay, coming to the second page. I'll come to the third page. Before that, I'll have to explain the second page. That see the example number 2. We come to the solution that it is the limit value of the limit is 0 by 0. It does not exist, right? Example of the 3. Just substitute. You will find that limit is coming to in the last line because the usual is what you are doing. What you're doing the same thing. Limit to in x tends to infinity 2 by x. That is 0. No problem. Okay. Next part. If fxy is equal to x plus y to x minus y, we have to show that limit x tends to a y tends to a fy is not equal to slipping. This marking is slipping. So yeah, here it is. So that is not equal to yeah, pointer is where is the pointer? Okay, it is not equal to the x tends y tends to 0, x tends to a fxy. So this can be done. First you take x tends to 0 y, then you take the limit x y tends to 0. It will be half. Is seen in the picture. The value of this is half. Then you take at first x tends to 0 and afterwards y tends to 0. The value is -1. So we can say this decision that this is not equal. If x tends to 0, limit y tends to 0, fx is not equal to the reverse. So these are the common problems that I have discussed. I think those are willing to learn. They have got it. I think there should not be any question. There are some exercises you can take it as a homework. Is it very hard? Is it very
No,
hard?
sir, very easy, sir. Very easy, sir.
Just easy one. Mechanically, it is easy one. If you want to go to the theory, limit value of the limit, taking the modulus, then it will be difficult for you. You don't have to do it. I am telling you. Then that if you want, I can give you the exercise, and also I can give you the literature. Then the diagram of interpretation. That is very important for you. Suppose this is the card. Z is equal to fx. Z is equal to fx plus y. Huh? This is the card. and I want to find out del z del x. Del z del x, because it is function of 2, y will be remaining at the constant. Suppose this plane is suppose this plane is y is equal to b. Just cut this at the point y is equal to b. So you will get a semicircular area split, is it not? If you cut it through y is equal to b, if you cut it, then you will get a semicircular curve. Then what is del z del x? Del z del x is nothing but at this point the tangent value of the tangent with respect to x, value of the tangent of z with respect to x. That is the curvature. That is value of the tangent means it is tangent means it is also a curvature also. So if you put this point to another pinpoint, p is equal to p dash, then tangent will be different. So del z del x will be found in any way. Z is equal to fxy. If you want to find del z del x, keep it as a constant. Keep y is equal to b as a constant somewhere. Not y is equal to b, y is equal to 2, y is equal to 3, anything else, still joining. So that is a problem. Y is equal to b, y is equal to 2, is equal to 3. Just cut this z is equal to fxy. You will get a semicircular area, and tangent at a point will give you the geometrical concept. You are finding out del z del x, finding out del z del y. You don't know what is the interpretation. That should not be there. So that is why I drawn this diagram from a rare book. That is meaning of del z del x. Z is equal to fxy is a curve, and if you want to find del z del x, just cut along y is equal to b. Y is equal to some constant. Then you find a semicircular curve, and at a point P, del z del x is value of that point, right? I think you are intelligent enough to capture this. If I want del z del y, then there a plane x is equal to a will be done in the same way, and the semicircular area that will give you the del z del x. This point should be clear. Yes, any question? I am not removing because there may be some question. This is the concept. I have found del z del x. It is written here. If you want, I will send you this. It is written there. I am wanting to find out del z del x. Actually, because it is if y is equal to b is there, then the function will convert to del z del f x b, and then you find the partial derivative. That is partial derivative. That is called del z del x. So for your convenience, I have picked up this. So this is very useful diagram. If you want to find del z del x, here this is the geometrical diagram. If you want z is equal to del z del y, then you have to keep x is equal to x as a constant. And suppose a plane will be there cutting along x axis, x is equal to a, then you will find the corresponding similar way. You will find out the del z del x, del z del y. This is the procedure. Okay, I'll just show you the full page. This is the full page. This is the theory how to find out the del z del x. Can you see it properly? And now I shall just find out the partial derivative. Some problems, but mechanically it is very easy. Theoretically, you have to remember this. Mechanically, is very easy. Coming to the next slide. That is it okay with you, or you are lagging something that I cannot judge this way, because you have to say me. You have to don't disturb the class. Just say me That I have stuck up here. I don't know. If you want, I can just give you the literature for your convenience. Now, this is the starting of partial derivative. Suppose del I want to find out del z del x. Z is equal to fxy. So del z del x and del f del x is same thing. See, sometimes it is written as fx, f suffix x. Uh, Sometimes it is written as whatever the story. Page 5. Yeah. Sometimes it is written as f suffix x. I am showing you in the here f suffix x, and sometimes and the actually the value is del z del x is equal to limit delta x tends to 0 f x plus delta x y minus f x y by delta x. So we know that it is the increment. Del z del x means it is the we know that derivative means it is the increment. It's not clear. Derivative dy dx means it is some increment of y with respect to x. That I have learned from the 12th level. Here, because it is a partial derivatives, if I want to find out the increment of the function with respect to x, that will be limit a delta x tends to 0 f x plus delta x y minus f x y by delta x, right? Because y is keeping constant. Because I am finding del z del x, y will be constant. So the definition will be limit delta x tends to 0 f x plus delta x y minus f x y by delta x. Similarly, now clear it. Similarly, del z del y, that is nothing but del f del y, nothing but fy xy, fy xy. Then del z del y definition is limit delta y tends to 0 f y x y plus delta y minus f x y by delta y. As a notation wise, sometimes it is called del z del x is equal to p. Sometimes it is called del z del y is equal to q. Sometimes you will see afterwards. P means we know it is del z del x. There is no special notation for this. Sometimes it will be mentioned that p into 2 plus p square, that means del z del x. P is del z del x, q is del z del y. Example number 1. Problems of partial derivative. Still admitting. Yeah. Example number 1. That if z into x plus y is equal to x square plus y square, so that del z del x minus del z del y whole square is equal to 4. 1 minus del z del x minus del z del y. You have to prove it. Watch carefully. What I have done, I want z. So the given expression is z is into x plus y is equal to x square plus. From that, I will find out z. Z is equal to x square plus y square divided by x plus y. Or is it all right? Z is equal to x square plus y square by x plus y. All right? Or
Yes, sir.
that's what. After finding z, just take a differentiation. Del z del x, because in the expression you will require del z del x, you require del z del y, that's what you want. You want del z del x, so give a derivative of z with respect to x, keeping y as a constant, because del z del x, y is constant. So uyv method, u into del z del x, del v del x minus E into del u del x divided by u v square. That is the differentiation formula, and that is equal to I am finding this result. And del z del y, similarly, u by v method, you will get this expression. Then del z del x minus del z del y, differentiate, you will get this one, 2 into x plus y, x minus y by x plus y. That much is clear. Left hand side, what you see, del z del x minus del z y is found out. Just square it because it is square is required. So this is 4 into x minus y whole square divided by x plus y whole square. That is simple mathematics. There is nothing too much to explain you. See, I am just how to find out del z del x I can teach you, but this simple differentiation, what will come, that will be the result. And the right hand side, 4 into 1 minus del z del x minus del z del y, it will come as 4 into 4 into, after putting the expression, because I am not putting you the all the expression and deduce it. The deduction part is your exercise. Deduction part is your exercise. From 1 and 2, we find out the result, right? Problem number 2. U is equal to sine inverse x by y. Are you sure? Because it is a BTech student, second year, so you should not hesitate it. So that is a very good one. Second year, this is not the first year. First year is simple mathematics. Second year is you have to take the partial derivative. There is no other way. So u is equal to sine inverse x by y plus tan inverse y by x. Then del u del x is, again, what is the ddx of sine inverse x? 1y root over 1 minus x square. That is 12 knowledge. And what is ddx of tan inverse y by x? This is 1 by 1 plus x square into minus y by x square. Minus, there will be two terms. No, that is equal to this one. And finally, the result will be this. This result. And del u del y. Del u del y will be found out. This is calculation. I will not show you. You take an exercise book and deduce it. But how someone has come now. So how can I continue? So after adding these two, you will get the corresponding result. Right? This is your job. If you want, I can send you the just problem by just try it as an assignment. And if you cannot find out, I'll just tell you, I'll show you how they have done it. Then find del u del r, del u del theta if e is equal to e to the power minus r cos theta. Okay, the textbook I will come to know, because this is not your textbook. This is from higher textbook. I will tell you the next thing. Next day I will tell you the name of the book. Usually it is Palendas. I don't know whether which one is available in your library. I will tell you in the next class. I'll just inquire and tell you. Then you have to, this way we are finding del u del r. This way you are finding del u del theta. Yes. See? Again another problem. You can note down the problem. No, that in library it is cannot be done. Okay, one thing. The one thing, these problems I can provide you. This literature is with me. From there, here you can practice it. I'll send in your group. You practice it. And book, you cannot go to the college and collect the book. That is true enough. B.S. Agarwal is good enough. There are other books are there. There is I.B. Prasad. There are other books. That is Chris Jick. But a lot of books are there. But yes, your question is correct. Okay, if you get it, the book PDF, then it is okay. No problem. So this type of, you can note it down. Example number 4, just take a differential partial derivative and getting the result, multiplying with it, because whatever you asked here, that is known to you. Now you find del u del x, now you find del x del u del x, then you find del u del y, x del u del y, adding it to result. These are all similar type of problems. More problem, okay, I can do one thing. It is so fast you cannot practice it. You have to practice. Better is, I'll send you this literature. From there you can practice it. Suppose you are stuck up in one time, then you can see, look into the note and check it. But you have to practice it. Suppose I give you the lecture, you don't know anything. Next class also you don't study anything. For your betterment, I can give you the notes I have collected, but you have to try it. Otherwise, it is very difficult. You do not try at the time of examination. At the time of examination, lot of maths has to be practiced. You cannot do it in 3 days. So then result will be not good. So better is right from the beginning. After I send it this, you just study the mathematical part. I have just found it for your benefit. So mathematical part, there are actually 11 problems are there. So you can try it. If you cooperate with me, then result will be very good. That's what I can tell you. Okay, I will send the literature. I cannot send to everybody. I'll just send it to the CR. He or she can send all. That will be better for you. So I have just, after initial discussion, I'm just ending my class. Now next class is scheduled to be on Tuesday. Tuesday and Friday will be my timing at 12 o'clock. Tuesday and Friday at 12 o'clock we shall I will come to the class. This is so far we knew from the authority that my slot will be Tuesday and Friday at 12 o'clock. Right? So just I'll send you after some time. I'll send you, and you practice from this book how to find out the partial derivatives. Okay, now I am closing this. Thank you. Just send me the just present classes. How many are present and what I'll have to mark it as presentation. How many are absent? How many are present? That data should be there. Just send it.
Yes, sir.
Thank you.
Thank you, sir.
Yes, Sneha, you want to say something? Yes, Neha, you want to know anything? You
No,
want
sir.
to
No,
know
sir.
anything? Okay, now your hand is raised. That's why it was.
Actually, just
Practice. Ah.
it was mistake, sir. Sorry.
Oh, okay, no problem. You have to practice this sums. Take a exercise book and put it and practice it. Maybe
Yes,
stuck
sir.
upside and you can see the note. Then it will go. I'll send the note to Share. He will discuss the deliver to you. Huh? Right.
Okay, sir. Hmm.
Okay.
Thank you, sir.